In this lesson, we will look at an application of rational functions. The problem. A box is to be constructed so that it has a volume of 400 cubic inches. If the length is twice the width, what will the dimensions be so that the box has minimum surface area? The solution. Here's our box. We'll call the width W, the height h, and the length L, and recall the length is equal to 2 times the width. The objective function here, we want to minimize the surface area, so our surface area function I'll call S. S is equal to the bottom area of the box plus the top area of the box, 2LW, plus the area of the two ends, which would be 2HW, plus the area of the front plus the area of the back would be 2L times H. I replace L with 2W here and simplify, so I have the surface area is equal to 4W squared plus 2HW plus 4WH. Adding these two last terms together, the surface area is equal to 4W squared plus 6WH. And let's next look at the constraint. So we know that our volume for the box is equal to 400 cubic inches. That means that length times width times height will equal 400 cubic inches. I can replace L with 2W, divide through by 2W squared, and have the height of the box is equal to 400 over 2W squared. So the surface area is 4W squared plus 6WH, and the height is 400 over 2W squared. Let's look at the surface area function and replace H with 400 over 2W squared. Simplify. And I want to have one fraction here, so what I can do is I can put the 4W squared over W by multiplying it by W, and then I'll simplify and end up with a surface area function of 4W cubed plus 1200 over W. Note this is a rational function. Our goal is to determine the dimensions for the minimum surface area. So now that the surface area function is in terms of one variable, I should be able to do that. We'll use Wolfram alpha here. I typed in local minimum of S equals and then typed in the function. Wolfram alpha told me that the minimum surface area is 60 times the cube root of 5 times 6 raised to the 2/3, and this occurs at a width of 5 raised to the 2/3 times the cube root of 6. Typing this width into a calculator, the width is approximately equal to 5.31 inches. Recall the length is 2 times the width, so the length here would be approximately 10.63 inches, and the height is equal to 400 over 2W squared, so the height, plugging my value for W in here, would be approximately equal to 7.08 inches. Try on your own, find the volume of a can of some sort, and use what you have learned here to find the minimum surface area of a can with that same volume.